Hey YouTube. So I was over in my greenhouse where I store my lumber, and I brought three 2x6s over here. I'm going to stretch them across these ramps I have and make a mock of the a mock-up of the wood miser frame, so I don't have to be out there in the cold trying to fool with this thing. And I'm going to take the toe board and start putting it together on the actual frame here. So then we'll be able to make sure that we can figure out anything that's not going to work right away. Guys, this is totally different than the toe board, although it relates to the lumber. This lumber has not been in the kiln. It's been in the greenhouse for, I want to say maybe 6 months. And you see it's at 19%. And 19% is normally what framing lumber is sold at. If you go to Lowe's and you buy framing lumber, the reason you see sap running in it at times is because it's at 19%. And that's what I have here. So technically this stuff would be perfect for framing. Now this is 2x6s here, and I'm not using it for framing. I'm going to use it, well, I am going to make a frame for the, as if it was the sawmill frame. So it's 30 inches apart, so I cut one board, I want to cut another. So while I'm at it then with this lumber, it was cut 6 inches wide, which you can see it has lost nothing in the width. But it was cut, the thickness of it was 2 inches, and you can see it lost about 1/4 of an inch in thickness. So this is just cutting on the sawmill, rough cut 2 inches by 6 inches, and now that it's dried down to 19%, it's 1 3/4 inches by 6 inches. So just thought you might want to know that. Okay guys, so the mock-up or wooden bunk frame you screwed together. You know that the cross bunk sits an inch above the wood miser frame on the LT15. They're 30 inches apart, which is what I have here. So this is going to make it a whole lot easier for me to put together, because I can measure right off of this and, you know, do what I got to do here. So the next thing is I have to drill 2 more of the uprights. I have them cut, I just got to drill them. And the good thing is, you can see now, this is floppy and everything else because it's not done yet. But the good thing is that this sits about 1 inch below the bunk frame, and that's what I need it to do in order to be able to be low enough that we can put logs on without them interfering with that. And then when they're together, I want it to be 4 inches above that. That's basically what this designates. You could tweak that a little bit, and I might as I go, by putting some different holes inside the uprights, but we'll check first, because I do have to round these off because I don't want them sticking above the toe board no matter what position they're in. And putting it on there was fairly easy, as long as you know, if you have somebody that can help you hold it up, it would be a lot easier. But you could always put some kind of shims or blocks or whatever underneath it to hold it. What I designed it was, I designed it to be 5/16 between the collar here and the frame. That's how the design was made. And I used a 5/16 bolt in there just to give myself the clearance that I need, so that I know that this thing's level with the bunk frame. So the next step is to build the other arms, like I said, and the cross member that's going to hold that thing straight up and down, and then we can go from there. Okay, so this piece here is going to be the cross brace that rides above the Acme screw now and holds the uprights from falling over. This is 29 and 7/8 I cut it, because I'm not positive if all wood misers would be exactly 30, because it's actually a 1/16 off, I believe. So making it just a hair short so it'll fit, hopefully, all the wood misers. So then I'm cutting on that pencil line, you can barely see it there, a 2-inch tab of steel. I'll cut 2 square pieces out of there and weld them to the end of this so they have an easy way to attach to the frame. These are the tabs for the cross member. I'm just going to drill 2 holes in there so I can screw them into the bunk frame then, or to the sawmill frame rather. In case you're wondering, these holes that I drilled here are 5/16, and they're drilled that way for the screws that I bought. Now this isn't going to hold anything like upright. It's not going to hold anything except itself. It just acts as a guide to keep that thing from sliding side to side. And also there'll be pins in here to keep it from falling over this direction. So I have to figure out where to put them just yet. Okay guys, so that's what it looks like on there so far. These have to be rounded and cut off. I'm not done with those yet. And I don't want bolts in there, obviously. I want pins in there so that it doesn't ride on threads. Now, this thing is about an inch below this bunk, which is just about perfect. Now, this will not go this direction, so that's fine. But you can see where this is what one of the guys had mentioned about it flopping back and forth, and it does. But I'm going to be putting some pins in the side of that other brace, right in this area, to be able to keep that from doing that. Now, is it going to be perfectly flat? It should be close. Does it have to be? It does not, as long as it picks the log up. But the making it perfectly level can be done with by taking the R-clips off and rotating that shaft, or I mean that coupling, so that the timing of this works properly. That's what I'm concerned about at the moment. But that's the brace that I put in there, okay, that runs through the middle. It protects the shaft from sawdust falling straight down. Now it's not going to keep all of it off there, but it'll keep a lot off. And it also keeps this thing from moving back and forth sideways. So now onward to the next thing. Alright guys, that's what it looks like when it's up. And the calculations of it all so far have worked out very well. So it's 4 inches, and you can see there, 4 inches above the bunk, and it goes down to 1 inch below the bunk frame here, and that's what I wanted. Because to me, I've never seen where I've actually had to put more than 4 inches on the bunk rail to be able to adjust the log. But I'm not saying it's, it won't happen, but all you gotta do is turn the log if that's the problem, and you won't have to put anything on top of this. Okay guys, so I just want to go over a little something here, and this is a part of construction project management. On my business card, when I was very active in construction, my business card said on it, construction procedure development. Now, if you've ever looked at a set of blueprints and there's a new type of product that's being installed, a lot of times the engineer will write out how it's to be installed. Like, not that it's put in upside down or doesn't work, but how to do it. And that's part of what I used to do, is develop the way to do things. Now, what I learned over the years, and I think this would be a good help to anybody, and we have a problem here. This thing will not stay up. It keeps wanting to fall over. I have a clamp holding this side. So the way you approach a problem like this is to say to yourself, what has some sort of consistency to it? What's constant about it? Well, when you turn the shaft on this particular problem, you have these uprights going in and out. So can I use those to stop this thing from going like this? I mean, they're the ones that are doing that, so how, can I do something to them? You probably can, but because of the way it's moving, you're going to have something a little bit elaborate on there. I'm after simple. Simple is always easy and cheap, and that's what I like. So then you must say to yourself, okay, since these move when they go up and down, and they're not in the same place, that might cause me a problem. But what is in the same place? What remains the same whether it goes up or down? And what that is the center of this goes over the center of that. You can hold that thing directly over top, crank it any way you want, and this thing will stay there because of the way the threads are working. Okay? So that's a pretty simple thought. Alright, so here now we have something that is consistent. It's not, where you have a million variables, and that's the problem. Whenever there's a problem that you're trying to solve, the more variables, the harder the problem is to solve. In a simple terms, just think of it like this. If you have a small family and you have one kid, you find out what the kid likes to eat. Okay, you're having macaroni and hamburger tonight. Fine. You know the kid likes that, there's not an issue. But when you have 6 or 8 kids and you say, okay, I'm making something for supper, what do you want? You get, at least 6 or 7 different answers. So you need to be able to solve these problems, even in something as simple as homemaking, and also you use the same type of thought process in construction work. So when I say to myself, okay, what on this thing is consistent? Keeping this level is important to us. Keeping this straight up and down here keeps that level. So in order to be able to keep that to go straight up and down, I figured, well, how can I keep this thing level all the time? You may be able to put some braces on here, whatever. I didn't even think about that. So what I came up with was this and this. And all I'm going to do is I'm going to weld this here, and I'm going to weld this on here. Now I'm going to do it straight so it stays, and that is going to keep this thing very close to level all of the time. Okay? So that is how this problem is solved. I'm going to put one on this side, one on the other side. I'm going to cut these off like I said before. But this is how you solve problems. When I started this, I didn't worry about it flopping side to side. I didn't worry about it flopping back and forth. What I was concerned with is that it would go below the bunk and 4 inches above the bunk. That's what the design was meant to do. And this does that. Okay? It does that. So as far as I'm concerned, as far as the design goes, this is a success. But I thought you might just like to hear how a person who solves problems. You think about all the variables that go with the problem. You try and reduce the variables. The first suggestion should always be the simplest, the least amount of variables, okay? After that, if that doesn't work, then you go to one that has maybe 2 variables or 3 variables. And depending upon how much engineering you have and how much knowledge you have about doing things and how things work, that will determine how well you're going to solve problems, especially in stuff like this. So, whether I have a problem with something breaking now, like maybe a weld break or whatever, that's something different that just needs to be corrected. But to make sure that it works as intended, that's the whole purpose of this. And once I weld these on here, you'll see how well this thing stays straight, stays flat, no matter what position it's in. Just thought you'd like to know that. So guys, and I've always liked construction. I've always liked construction project managers who are good ones. There's a lot of not so good ones. Some people just don't know how to solve problems and are in it for the money. I was in it for the love of construction. I love it to this day. I would, believe me, if I wasn't as old as I was, I would be definitely doing more of it. No matter what it was, whether I was in water or snow or in dry land, I loved doing it. So anyway, I just thought you'd like to know that. So I'm going to weld these up and then I'll show you what it's like after I'm done. Okay guys, so I took this board out of here that represented the bunk just so I could work with this. Now you can see it's solid in both directions. This way here has a little wobble to it. It needs, the weld needs to be ground off and some shims put in there, so I'm not worried about that at the moment. But that's not the point. It's not going to fall over. And besides, once it hits the log, it's going to hold itself wherever it is. So that doesn't matter. So let's crank this now, and we'll turn it down. Okay, so let's see here. You can see, I need my tape measure. You can see where it's a little bit off coming down here. This is 3 inches. This is 3 3/4 inches. So we can adjust that by taking these R-clips out of here and turning the rod. Like, we need to raise this up a little bit. So that means that that pin point has to go that direction ever so slightly. Okay, so we're going to do that now, and then I'll get back to you. Okay guys, so I pulled the R-clips out and adjusted that nut there. Part of the other problem is I'm using the holes that were existing inside this thing, and you can see there's a little slop there. What we have is they're 3/8 and I have a 5/16 bolt in there, so I need to replace that. But roughly we got 3.5 inches on both sides of that thing. So now we're going to crank it back up again and see how that looks when it's cranked back up. Definitely got to have something better than a pipe wrench for this. So there we're all the way up. Let's just see what we have here. We have 7.5 inches there and 7.5 inches over there. So the timing then is good on this. Now, like I say, you can see that we do have to put a bigger, this here, I'm not sure what size hole I have in here, but I know that that's not a 3/8 inch, or it's not the right size pin in here. I believe that this hole that was in this thing is oh, I don't know, let's see, it's not 3/8, so that would be 6/16, 7/16, I think that's a 7/16 hole, okay, or maybe even slightly bigger, and I got to make these all the same hole in here, so I'm going to have to run a drill through that. The other things on the bottom there are fine as they are. So let me take this back down again now and see how it goes down. My problem here is I don't have a socket big enough to fit these nuts. I could weld something up there. I'm not worried about that. My problem is I just don't want to have to do it at the moment. Okay, so we're back down there. Let's see what we have here. We've got 3 inches there. We've got about 3.5 inches on that side, but if I pull that slack out of there, 3 1/4. So that's what needs to be done. I need to put a nicer sized bolts through here instead of this sloppy thing in here. Okay, it's not this that's the problem. It's the bolt holes. You can see they're moving there. So once I drill them out, we'll be fine. The other thing I want to do is I want to cut these off here. I guess I could cut them off straight. It's not going to matter anymore. And then that's it. So I would say that this is a successful build. I'm not quite done with it, and I'll show you what I mean about shimming up and the weld. If you look down in between here, you can see that there's some rough weld there on both sides that needs to be ground down, as well as, let me take the camera off of here, as well as if you look down there in between here, there could be a washer on there on both sides to tighten that up a little bit, and that's what it's going to need, and I can adjust that with, you know, washers. It's that simple. So guys, that's how I would make a toe board for the LT15. I don't like the one that comes from the manufacturer. This is a little more involved than that is, but I like this a whole lot more because you'll be able to pick up logs. You figure the dog or the stop comes out here this far. You can pick up any size log with this thing. So let me finish it up, clean it up, cut those pieces off that are in my way, and then we should be in good shape here. And I got to put some new heavier bolts through here so that this is nice and tight. Okay guys, so one more time. All I did was cut the uprights off. I need to grind them so that they're rounded a little bit and stuff. I probably have another day's worth of work to do to this thing, but I want to show you. The toe board needs to be below the bunk, so that when you put a log on here, it can lay flat. When you put a cant on here, the toe board needs to be below the bunk, because if it's not below the bunk, you're going to have trouble, and there it is, below the bunk, you're going to have trouble with cutting cants. So that's why it has to be below. So then I'm cranking it clockwise, and like I said, I didn't get a chance to put the right size pins in there yet, but about 3 3/4 inches above the bunk, so it might be slightly low, although like I say, once I put the right pins in here, I'll be where I want to be. So that's it. That's a toe board, and like I say, you're looking, the edge of that toe board is 3 inches away from the edge of the frame. Now, if you know anything about the wood miser, you know there's some stuff going on here within that distance with the saw head. So we don't want it completely across. And the way it is right now, looks like it would be just right. So I want to grind these off. I got to get the right pins in here, grind off some of my welds here and there, and that's it. So as soon as the weather changes, I'll be putting this on the wood miser. I want to paint it up, shim it up, make sure everything's good with it, and then I'll go from there. So guys, whenever you're looking at a set of drawings, and I was, people were saying to me that it won't work as it is. That's true, it wouldn't work as the drawing was, but I wasn't done with the drawing either, and I just needed the working mechanism to, once I figured out how I was going to make it go up and down. And listen, the whole point of this is that it's manual. It's a manual mill. This thing is manual. You can put anything on here you want to make this thing go up and down electrically or with air, electric, a drill, I'm sure would do it. I don't know how much torque it's going to take to pick up a log. That's something I don't know yet. But I don't think it's going to be much, because if you think about it, a car jack uses a much smaller thread than what I have, a much smaller screw, probably half that size, maybe ½ inch, and it picks up a car which is about 2 tons in the front, or a pickup truck anyway, in the front end, this should have no problem picking up a log. I don't see that it would. Let me just show you some of the other things I did here that I didn't show you today. I also drilled and put a set screw in these nuts here on this side as well as the other side, because when I started turning it and everything, they wanted to turn away from the frame, which, you know, I didn't want that. So yeah. So it took me a couple of days to put this thing together. Not sure exactly what it cost me at this point. I haven't added everything up yet, but I will. And a lot of the guys gave me some good ideas for some other ways of doing this that might work even better. So not necessarily the way the toe board's working, but how I built it. A couple other little things that would be good. I've also put some grease in the fittings already that I had there. I don't know if you can see the grease. Yeah, you can see it there. And see, the thing is a toe board is not used to cut, to make exacting cuts. It's made to pick the log up so you can get straight cuts, or get cuts that are going to keep the center of the log where you want it. You may want it dead center, you may want it high or low, but either way, that's what the toe board will do. Alright guys, well, I got grinding stuff all over the garage here. Bullseye's looking like he's gray instead of white, so I think I've had enough for one day. What the time is it anyway? Okay, 4 o'clock. 4 o'clock on Friday, right? So I need to clean up after myself so I can get the truck back in here, because I think it's supposed to snow or rain tonight or tomorrow. Alright guys, so if you have any questions, leave them on the comments and stuff, and I'll get back to you. I need to, like I say, I need to do some final touching up and tweaking, and I'll be in good shape. Thanks for watching my channel, guys. Thanks for commenting. Really appreciate it. Have a good one.